Okay, so this will be the first time you've seen a problem like this, so I wanted to run through what it looks like. Pushing up a block up a ramp, no friction. So if there were friction, by the way, that would show up here as work done by an external force. Another work done by external force is the person's pushing. So those are both external forces. And also, importantly, non-conservative forces. Conservative forces are things like the force of gravity and the force by a spring. But in this case, there is no spring. So I can tell you right now, initially, there is no energy in the spring, and at the end, there will be no energy in the spring. What about, let's see. So we have gravitational 0 point is here. So this H is 0, we're going to say, and therefore MGH, gravitational potential energy, is also 0. Here it would be something other than 0. We have gone up. The H would have increased by this much, the change in height. We are pushing it up, let's see. They're pushing it up at constant speed. What does that tell us? So that tells us that whatever the kinetic energy is at the start, and I really don't have any way of knowing, but it has some kinetic energy. I'll just pick an amount. How much? 3 bars. How much will it have at the end? Well, it'll have to have 3 bars because the speed is constant. Now, if we call where it started 0, that means it had no potential energy at the beginning, and it had some at the end. I will now put in, let's say, this many bars. 5 bars. So at the end, we'll say it has 5 bars worth of, potential energy. Now, here's the deal. What you start with, plus what non-conservative forces add or subtract in this thing, has to be the same total as what you end with over here. So these two in red combined have to add up to whatever's over here in blue. So in this case, well, it's a straightforward problem because I added 5 joule or 5 bars of gravitational potential energy. And I didn't start with any. So all that increase in potential energy had to come from the work done by the external force, the push. So that the pushing force, my board is suddenly causing headaches to me, but 1, 2, 3, 4, 5. So right in here, there we go. This needs to be 5 as well, because this work done by a non-conservative force, the hand pushing, gravity is an example of a conservative force, has to be where this potential energy came from. Because we didn't change kinetic energy, it was the same here and here. We didn't have any potential at the start, we end up with some at the end, and spring energy is 0 in both cases. All right, there you go.